In 2006, Martin Fowler, your friend, wrote that you coined the term polyglot programming to express the idea that applications should be written in a mix of languages to take advantage of the fact that different languages are suitable for tackling different problems. So can you tell us the process that led you to coming up with the term polyglot programming?
If you go back to 2006, when I came up with that, that was really the beginning of the kind of Cambrian explosion of languages supported on both the JVM and .NET. .NET was specifically designed to support multiple languages, but the JVM came out strong too. And it was a bit of engineering brilliance, I think, on the part of the JVM to separate the runtime from the language and have basically an assembly language that runs the runtime, because it allowed them to innovate on the runtime without affecting the language and vice versa. Computer languages can't be objectively evaluated because it's a creative medium. Every person finds the creative medium that they like to push against that allows them to be creative. There's a great quote that I bring up here from William Faulkner, the Nobel Prize winning novelist. And he very famously has a quote that said, "I started out as a poet and I was terrible as a poet. So then I tried writing short stories and I was terrible at that too, so I guess I'm a novelist." But he discovered what his kind of, the real secret to creativity is not freedom, it's constraint. It's the right kind of constraint to push against.
You talk about a creative preference in terms of a language. What about a functional preference, where a language is just better suited to a purpose in a polyglot?
Well, there are certainly cases of that. So the only person that I know that has Haskell code in production, and that's a pretty rare thing because Haskell's a great way to think about things, but man, you do not want to put that in production and argue with like I/O and stuff like that forever. But our CTO, Rebecca Parsons, actually talks about some code that was production ready that she created in Haskell. And she said, they were doing like signal transformation process and all this really heavy math. And it was like a hand in glove fit for that language. And so there's a lot of the affordances the language offers you to get stuff done. At some point, they're all Turing complete. And so, anything you can write with assembly language, you can write with Erlang or Ruby or C#, but it's how difficult it is to write that and what affordances does it give you.
Is that what you're finding? Is microservices a natural fit for polyglot programming?
It is, because there's such a level of isolation. Of course, it's based around this idea of a bounded context. So when you think about governance in architecture, there are two philosophies. Software is either overhead or it's strategic. What do you do with things in an organization that are overhead? You minimize cost, because the more you minimize the cost of overhead, the more profit you make. One of the great revelations in microservices is like, stop. Simple things can have a simple tech stack, PHP, MySQL database, done. We'll get it done in a week and we're over, versus Java, Maven, Oracle, Enterprise Service Bus, the whole technology stack. And so in our Building Evolutionary Architectures book, we actually introduced something, and this is the hazards of writing a book. We introduced something that we call Goldilocks governance. And then we realized after we published the book that only people in Europe and the US know who Goldilocks was. Nobody in Asia or anywhere else knows the Goldilocks fairy tale. But of course, the idea was finding the just right fit for these things, not too much, not too little. And the idea of Goldilocks governance is, let's pick a few technology stacks, a simple one, a medium one, and a complex one, and standardize on those rather than one size fits all or, one unique one for everybody. And I think microservices really facilitates that because it does have that extreme level of decoupling.
We're often telling people is the difference between a low-code solution and a no-code solution. It's that critical last few percent where to get the job done, you really need to code.
Exactly.
To be able to get there and build it is whatever that custom function is or custom workflow or whatever it is that you're trying to build, is you ultimately want to be able to write some sort of script, some sort of library, object, whatever it may be that you can call into your low-code application.
I will use your low-code environment if you will give me the following things. I want the ability to diff it, I want to be able to version it. I want a first-class IDE that gives me refactoring support. I want to be able to test it at the unit, functional, and user acceptance level because I get all those things with code. And so if you're going to make me go to a different low-code environment, I want all those things because that's a trade-off. First thing you want to do is do the most difficult thing. Because you know the easy stuff is going to be easy. If it's not, then what are you doing? You need to make sure how far you can push it to see where that 10% is going to fall. And so the first thing you should do is the most difficult thing because that's where you're going to find out that the transactionality doesn't work or the scalability doesn't work or you can't get enough access to the underlying data to make it work. That's the way to vet a low-code environment.